Hello and good day. The topic of our discussion today is what is a prime number in general math. At the end of this tutorial, we will learn what is a prime number and the process of determining the prime number. Let us see the definition of prime number first. A positive integer that is divisible only by itself and 1. It means that the number must be a positive integer and the number will have a remainder if it is divided by any other integer than its own and 1. Now we look at some examples of prime numbers. The first number is 2. This is a positive integer if 2 is divided by any integer other than itself and 1. The division will end up with a remainder. So 2 is a prime number. In the same way, 3 is a positive integer. Dividing 3 by itself, that is 3 and 1. But if divided by any other integer than these two integers, the division will end up with a remainder. So 3 is a prime number. The next number is 4, which is a positive integer. But dividing 4 by itself, that is 4 and 1. Apart from these two integers, 4 is also divided by 2 and it will not end up with any remainder. So 4 is not a prime number. The next number is 5. This is a positive integer. Dividing 5 by itself, that is 5 and 1. If divided by any other integer other than these two integers, the division will end up with a remainder. So 5 is a prime number. The next number is 6. This is a positive integer. But dividing 6 by itself, that is 6 and 1. Apart from these two integers, 6 can be divided by 2 and 3. Will not end up with any remainder. So 6 is not a prime number. The next number is 7. This is a positive integer. If 7 is divided by any integer other than its own, that is 7 and 1, then the division will end up with a remainder. So 7 is also a prime number. Now the prime numbers from 1 to 7 are 2, 3, 5 and 7. Some of you may have a question in mind why 1 is not a prime number. We will come to learn that soon. Just hold your horse for the time. The characteristics of prime numbers. The characteristics of prime numbers from the above examples can be portrayed as follows. The first characteristic of prime number is that the number must be a positive integer. It means neither it can be a negative number nor a fraction. The second characteristic of a prime number is that it will be divisible without any remainder only if it is divided by itself and 1. The third characteristic of a prime number is that it has two unique factors, which are the number itself and 1. But it is very important that the number itself and 1 cannot be the same number, must be different to each other. Now, the question may arise, is 1 a prime number? To understand whether 1 can be included in the prime number or not, only by analyzing 1 in context of the characteristics of the prime number. The first characteristic of a prime number is that the number must be a positive integer. 1 is a positive integer. The second characteristic of a prime number is that it will be divisible without any remainder only by itself and 1. Dividing 1 by itself and 1, it does not have any remainder. So it complies with the second characteristics of prime number. The third characteristic of a prime number is that it has two unique factors, which are the number itself and 1. But in case of 1, it can be divided by only one number, and that is 1 itself. Therefore, considering the third characteristics of a prime number, since the two factors of 1 are not unique, 1 is not a prime number. It is important to remind that mathematical definitions evolve over time. Throughout the history, many mathematicians have considered 1 to be a prime number, although this is no longer the generally followed approach anymore. We will determine the prime number using the sheaf of Eratosthenes. Before that, it is necessary to know a little bit about the sheaf of Eratosthenes. It is a method of finding the prime number by writing the numbers in order of value from 2 to the top, and every third number after 3, every fifth number after 5, every seventh after 7. And thus, by multiplying the multiple of the numbers. The numbers that remain are considered to be the prime numbers. We will determine the prime numbers from 1 to 50 using the sheaf of Eratosthenes. However, it is an earnest request to the students using the same process to find prime numbers from 1 to 100. It will give confidence, and also the quality and durability of the education will be better, because practicing mathematics is an integral process of learning mathematics. We have already seen that 1 is not a prime number, so we will cancel it. The next number is 2. Let us mark 2 as the prime number. Now, let's cancel the multiples of 2. Obviously, 2 is the only even prime number and at the same time the smallest prime number. In many cases, the question may arise as to which is the even prime number or which is the smallest prime number. And for both the questions, the answer is 2. Let us go to the next number, which has not been cancelled yet, that is 3. Let us mark 3 as the prime number. Now, let us cancel the multiples of 3. Some numbers have already been discarded, but we will discard them again so that we can see the multiplicative numbers and understand clearly. Hopefully, the students have understood the process of using the sheaf of Eratosthenes. The next number that is not cancelled yet is 5. Let us mark 5 as the prime number. All multiples of 5, that is, void all the numbers has 5 or 0 at their end. The next prime number is 7. Now, let's cancel the multiples of 7, that is 14, 21, 28, 35, 42, and 49. The next prime number is 11. Now, let's cancel the multiples of 11, that is 22, 33, and 44. The next prime number is 13. Now, let's cancel the multiples of 13, that is 26 and 39. The next prime number is 17. Now, let's cancel the multiplicative number of 17, that is 34. The next prime number is 19. Now let's cancel the product of 19, which is 38. The next prime number is 23. Now let's cancel the multiplicative number of 23, that is 46. Now the remaining prime numbers from 1 to 50 are clearly visible, which are 29, 31, 37, 41, 43, and 47. Hopefully, the process of determining prime numbers using the sheet of Eratosthenes is clear to you. Practice makes a man perfect. In mathematics, to achieve the efficiency is only possible the more you practice, the more you learn. Thank you for watching the tutorial. If you have any question, please send us email to rhkstorecouk@gmail.com or write in comment section. We would appreciate if you subscribe, give us a thumbs up or a like. Please do share with your friends, and to receive new tutorials, do not forget to press the bell icon. Stay home and stay safe.